first? Do I think of myself first? Or do I...
Hi everyone, my name is Gianna Gonzalez, and today I'll be teaching you the physics behind defenestration. Defenestration is also known as jumping out of a window. Here we will discuss freefall, kinetic and potential energy, and collisions. First, let's go over the basic kinematic equations. D equals VIT plus 1/2 AT squared. VF squared equals VI squared plus 2AD. VF equals VI plus AT, and D equals 1/2 the quantity VI plus VF times T. In these equations, VI equals velocity initial, VF equals velocity final, D equals distance, A equals acceleration, and T equals time. First, we're going to start off with a freefall problem. Say you're at the window of the top of a story of a building at the height h. Your initial velocity will always be equal to 0, as you are starting from a stationary position. When you go to find the final velocity, due to it being a vector quantity, the value will be negative. Now, this isn't because you're slowing down, it's because you're going in a downwards direction. A positive vector means you're going up, while a negative means you're going down. When working with freefall, your acceleration is always negative 9.81 meters per second squared, because that is the acceleration of gravity. That acceleration is always applied to free-falling objects. Your height will be your distance in any given kinematic equation. Your time can be calculated as needed. So now that the basic concepts are covered, let's do an example problem. Say you are given a time of 3 seconds and a height of 12 meters. You already know that your initial velocity is 0 meters per second, and your acceleration is negative 9.81 meters per second squared due to the gravitational constant and starting from a stationary position. From this information, you know that you have to find the final velocity. With these numbers, you can use any of the formulas that include velocity final. For this example, we'll use VF squared equals VI squared plus 2AD. You would leave VF squared as is, then plug in 0 for VI, negative 9.81 for A, and 12 for D. You end up canceling out VI, and what remains is VF squared equals negative 235.44. Now you have to square root this to find VF, which presents itself a problem. You cannot square root a negative. However, this negative is only used to present a direction, so you can ignore it when doing the math. Just don't forget to add it back in for the final answer. Here, you end up with a rate of hitting the ground at negative 15.34 meters per second. Now let's do an example where you have to find time when only given a final velocity. You know that your initial is going to be 0 meters per second, and your acceleration will once again be negative 9.81 meters per second squared, but this time no distance is given. You would have to use a kinematic equation that both has time and doesn't have distance. Luckily, we have the equation VF equals VI plus AT. The VF given will be negative 96 meters per second. So, now that you are finding T, you will have to rearrange the equation a bit. Keeping things as variables, you can change it to VF minus VI divided by A equals T. VI is equal to 0. So you end up with negative 96 divided by negative 9.81 equals T, and T will equal 9.79 seconds. When you divided the negative 96 by the negative 9.81, the negatives canceled out, and you ended up with a positive T. Then you found that T equals 9.79 seconds, and that is the amount of time it would take for the free-falling body to hit the ground. Let's say that using the variables you were just given and the time you just found, you have to find the height of the building from which the person jumped. Well, then you can use the equation D equals VIT plus 1/2 AT squared. VIT will cancel out because VI is equal to 0. So you are left with D equals 1/2 AT squared. You plug in the numbers for A and T to get D equals 1/2 times negative 9.81 times 9.79 squared. You will end up with an answer in the negative. But because distance cannot be negative, you can treat your answer as an absolute value. The height ends up being 470.12 meters high, and that is the height from which the person jumped. Now that we generally understand that side of defenestration, let's look at it from an energy point of view. We'll start off by defining the energies we'll talk about. Potential energy is the energy by which a system holds within the ability to do work. Kinetic energy is the energy possessed by the system while in motion. These energies are conversely related to each other due to the law of conservation of energy. Energy cannot be created nor destroyed, only changed. To discover the energy of the system, specifically, we will use the concept of gravitational potential energy. This has a formula of its own. W gravity equals mgh. The gravitational potential energy is the same as gravity done by work in this problem. M is equal to mass, G is equal to gravity, and H is height. In this type of problem, distance is only ever measured in height, as gravity only affects those systems going a vertical distance. Also, energy is a scalar quantity, so the negative given in gravity's acceleration can be disregarded. The final product is measured in joules. So now let's do a sample problem. Say our man jumping from our window has a mass of 16 kilograms, and the window is 8 meters high. Well, then when we multiply the height by the mass by the gravity's acceleration, 8 times 16 times 9.81, and end up with a gravitational potential energy of 1,255.68 joules. This number will be your starting potential energy, just before he jumps. Because kinetic and potential energies work conversely with each other, here kinetic energy equals 0. Now, as the man jumps and begins to fall towards the ground, the potential energy decreases and kinetic increases to make sure the energy is always conserved. In this problem, we will measure him going down in increments of 1/5 the whole distance. As the man falls, his potential energy decreases by 1/5, while his kinetic energy increases by 1/5. When you add the kinetic energy and potential energy at any given increment, they will equal the original amount of energy, showing that energy is conserved. Right before the man hits the ground, the entire 1,255.68 joules of energy will be kinetic, and the potential energy will now have dropped to 0 joules. So to end our little physics behind defenestration explanation, let's discuss how defenestration ends, finally touching base with the ground. There are 3 types of collisions in physics: elastic, inelastic, and completely inelastic. This particular situation would represent a completely inelastic collision, as the person will not be bouncing back up after hitting the ground in any notable way. With this type of collision, linear momentum is maintained while kinetic energy is transformed to internal energy. When we are looking at inelastic collisions, we are aiming to find the change in energy. To do so, you need the mass of the person, the time it takes for them to stop, and the rate at which the person decelerates when hitting the ground. So let's do our example problem now. We have our man here with a mass of 20 kilograms now, and he's jumping out of this window. Just for the sake of perspective, let's say he's falling at a rate of 50 meters per second from a 75-meter tall building. You won't need that information, it's just there to paint a picture. It'll take this guy about 0.1 seconds to come to a complete stop when he hits the ground. His acceleration at this point will be negative 100 meters per second squared. Now, with this information, we can find the force at which he hits the ground. We multiply mass by acceleration, 20 times 100, to equal a force of 2,000 newtons, disregarding the negative here. To find the change in energy, you multiply the force by the time it takes the body to stop, in this case 0.1 times 2,000. Then you find your change in energy is 200 joules. Alright, so that's about it for my physics behind defenestration presentation. I hope you have come to a better understanding of free fall, energies, and inelastic collisions. Please just don't test these problems out by actually jumping out of a building. Thank you for your time.